Mass of capital M kg is suspended by a weightless string. The horizontal force that is required to displace it until the string makes an angle of 45 degree with the initial vertical direction is, right. Now let us see the question, what it is saying. Now this is a mass, right, and this is of m kg. Right, now we apply a force F, so that eventually what happens is this block comes in this position, that is basically making an angle of 45 degree with the axis. So basically we need this force which can take it up to this point. Let us suppose this is A and this initial point was B and this point is, let us suppose, C, right. Now let us draw a perpendicular from this. Let us mark this point D, right. Now you have to see over here, we are not talking about the force which is acting when it is in this direction, right. That means most of the students might be confused that, you know, over here we're talking about this force. Like, let us suppose this force is acting F, so this is mg. So a lot of students will be, you know, doing what they might be making the block in equilibrium in this direction, right, in making an angle 45 degree, but we do not require this force. We require the force which can take it up to the point C, right. So how can we calculate this force? Although the force is same, but you know, it is varying. Why it is varying? Because what is happening at every point, tension is changing because the angle is changing. Let us suppose it is at this point, the tension at this point is acting in some other direction. Earlier it was in the vertical direction. So using the force equation, this might not be a good idea, because at every point the tension's direction is changing. So what we can do, we can use conservation of energy, right? Because if the force is acting on the horizontal direction, then how much distance has it moved? That has moved CD distance, right? So that means work done by force F is F dot CD, right? This much work has been done. Now this work has been done, and this will be equal to the change in the mechanical energy of the system. What is the change in the mechanical energy of the system? It has actually gained a potential energy, right? Now initially it was, if this was L length, this is also L. Let us redraw the diagram. Right, if this is making an angle 45 degree and initially it was here, finally it is here, and this is A point, this is D point, this is B point, and this is C point. If this entire AB is L, that means AC will also be L, because this is the length of the string. So what will be AD? It will be L cos 45 degree, right? So what will be the gain in height? If this is H, this is how much this H height this block has risen, right? So H will be equal to what? L into, that will be basically AB minus AD. What is AB? AB is L, and what is AD? L minus L cos 45, right? So this will be the height H, or we can write it as 1 minus 1 upon root 2. So this much height it has risen. That means F dot CD, this will be equal to mg into H, or L into 1 minus 1 by root 2. Now what is the distance CD? It will be what? L sine 45. That means FL sine 45, or I can write it as 1 upon root 2 will be equal to mgl into 1 minus 1 upon root 2, right? So L and L I can cancel out. That means I can write F will be equal to mg into root 2 minus 1. So that means option D is correct.